Hello to all. I'm Dr. Alkesh Agrawal, and in this lecture, I'll mainly discuss how to analyze synchronous sequential circuits. So, these are some reference books that include Digital Design by M. Morris Mano and M.D. Saletti, and one is Modern Digital Electronics, authored by R.P. Jain. So, this is the first synchronous sequential circuit in which you can see there is one D flip flop, and to the input of D flip flop we have two logic gates in terms of exclusive OR gate. In the first exclusive OR gate, one of the input is connected to the output of D flip flop, that is QT, and in another exclusive OR gate we have two external inputs A and B, and the output is connected to the input of the first exclusive OR gate. So this is a example of a sequential circuit, and we have to analyze. So generally we have two processes, one is called analysis and one is called design. So in analysis process, what is given is the sequential circuit, and we have to study the behavior of the circuit in terms of the generation of state table and generation of state diagram. Whereas in design process, what is given is the state table or the state diagram, and we design the sequential circuit. So in this particular lecture, we'll see how to analyze the sequential circuit. So for this, first we'll generate the state table. So in this particular slide, you can see we have this synchronous sequential circuit, and this is the design of a state table. So in the state table, we have different columns. In the first column, we have the present state of this flip flop, D flip flop, the inputs that we are giving, external inputs in terms of A and B, and the next state. So we can see that input is the exclusive OR value of this DAT, which is being fed back from the output of the flip flop to the input of our exclusive OR gate, plus A and B. So at the input of the D flip flop, we have exclusive OR value of A, B, and DAT. So we have written DAT. This is the input that is from the output of flip flop, and external inputs A and B. And then we are calculating DAT plus 1, that is next state. So the DAT is the previous state and DAT plus 1 is the next state. That depends upon the previous state, external inputs A and B. And we know this is an exclusive OR value. So we know very simply that if we have odd number of ones, the final output is 1 for exclusive OR operation. If we have even number of ones, the output is 0. So here you can see we have made a table. Since there are two inputs A and B, so we have the combination of 0 0 0 1 1 0 and 1 1 with previous output or previous state as 0 0 0 0. Again we have the same kind of inputs as 0 0 0 1 1 0 1 1. Now in this case we have assumed the previous state is 1 1 1 and 1. So like this we have a different combination, and if we see the value of DAT plus 1, so what we have calculated is the exclusive OR value that is coming onto the D flip flop, and we know whatever that comes at the D flip flop, the same will be the next state of the D flip flop. So what is coming is exclusive OR value of DAT A and B. So all the values are 0. So DAT plus 1 is 0. Then in this combination of 0 0 1, we have 1 1. So exclusive OR value is 1. Again, next combination is 0 1 0. So the final exclusive OR value which is coming onto this D is 1, and that is the next state, that is 1. Then we have 0 1 1. For 0 1 1 combination, the exclusive OR value is 0. For 1 0 0 combination, exclusive OR value is 1. For 1 0 1 combination, exclusive OR value is 0. For 1 1 0 input, exclusive OR value is 0, and for 1 1 1 exclusive OR value is 1. So like this we made a state table, and now on the basis of the state table we will generate a state diagram. So here the external inputs are A and B. So here again I have also shown the state table, and on the basis of the state table we'll see how to generate a state diagram. So again, the state, because we are using only a single flip flop, T flip flop, so for that single flip flop we have a state 0 or state 1. So if we see the first row, here the previous state is 0 and the next state is the same 0 for the inputs, external input 0 and 0. So we have the self loop where this tail points to the previous state and the arrow points to the next state. So from 0 to 0 with input 0 0. Then the next is from 0 to 1 with input 0 1. So we have this kind of transition from 0 to 1. So the tail is towards 0 and head is towards 1 with input 0 1. Then next is from 0 to 1 with input 1 0. So again we have the same transition from 0 to 1 with input 1 0. Then next row is from 0 to 0 with inputs 1 1. So again we have this transition, self transition from 0 to 0 with input 1 and 1. Then the next row, for the next row we have transition from 1 to 1 with input 0 0. So we have this self transition from 1 to 1 with inputs 0 and 0. The next transition is from 1 to 0 with input 0 1. So we have this transition 1 to 0 with input 0 1. Then we have transition 1 to 0 again with inputs 1 0. So we have transition 1 to 0 with input 1 0. And the last is the self transition 1 to 1 with inputs 1 1. So we have this self transition from 1 to 1 with input 1 1. So this is how we analyze the given synchronous sequential circuit in terms of state table, and we generated a state diagram from that state table. So this is the process how we analyze a synchronous sequential circuit. Now let us take another example, somewhat complicated. So here we have two flip flops which are T flip flop, that is toggle flip flop, and we have external input as X and external output as Y. So Y is A and B. What is A is the output of TA flip flop, and what is B is the output of TB flip flop. Then what is input to TA flip flop is, you can see we have an AND gate. One of the input to AND gate is external input X, and another input is, you can see, is connected to B. So TA input to A flip flop TA is B and of B and X. Then you can see over here TB is connected directly to X. So we have TB is equal to X. So these are inputs, and output is, I have already told you, A and B, and the external output Y is A and B. So now we will analyze this circuit again in terms of a state table and a state diagram. So we have again generated a state table. Again we have present state. So here, because we have two flip flops, one is TA and TB, and one output is A and another output is B. So we have written under the heading present state AT and BT. One represents the previous state of A flip flop, another represents the previous state of B flip flop. Then we have external input as X, and here we have calculated the input to TA is B and X and input to TB is X. Now based on these inputs, we have to calculate the next state, which is AT plus 1 BT plus 1, and this is the output. So first is input to TA. Input to TA is B and X. So B is previous state is 0. We assume that both the outputs are 0 0. That is previous states of A flip flop and B flip flop are 0 0, and again we give input as 0. So B and X 0 is 0 and X is 0. So at both the inputs of T and TB, we have inputs 0 and 0. So the toggle flip flop are not activated, and the next state are same as previous state. So AT is 0, AT plus 1 is 0, BT is 0, and BT plus 1 is 0. Because why this is 0 0? Because TA and TB are not activated. They will only be activated when values are 1. So now we see another condition. Here you can see how we have represented present state and input is we have taken two conditions 0 1 0 1 0 1 0 1, and since they are two states, so we have taken the combination 0 0 with 0 external input, 0 0 with 1 input, again 0 1 with 0 input, and 0 1 with 1 input, 1 0 with 0 input, 1 0 with 1 input, 1 1 with 0 input, and 1 1 with 1 input. So like this we have written the combinations. Again and 8 different combinations. So let us see second row. Here BT is 0 and X is 0, the AND value is 0 and X is 1. So now TA is 0, since TA is 0, so AT is 0, so AT plus 1 is 0. There is no change in the state, and since TB is 1, so there is a change in state in BT from 0 to 1. If we see the third row, we have B is 1, X is 0. Again, the AND value of B and X is 0 and X is 0, so both values are 0, 0. So again, there is no change in the state. A is 0, so AT plus 1 is 0, and BT is 1, so BT plus 1 is 1. Then we see another combination as 0, 1, 1. So BT is 1, X is 1, so AND value is 1 and X is 1. So both TA and TB are activated. Now there is change in state. So AT is 0, AT plus 1 is 1, and BT is 1, so BT plus 1 is 0. There is a change in state because TA is 1 and TB is 1. That depends upon B, X, B, and X. If we see another row, we have inputs 1, 0, 0. So B and X is 0 and X is 0. So again, at both the T and TV, we have values 0 and 0. So the toggle flip flop is not activated. So AT is 1, it will remain as 1 as AT plus 1. And BT is 0, so BT plus 1 is also 0. Again, next row is, for next row we have 1, 0, 1. So TA, which is product of B and X, is 0 and X is 1. So TA is 0, so AT is 1, AT plus 1 will remain 1, and TB is 1, so the state of B will change from 0 to 1. So from 1, 0 we have state to 1, 1. Now we have state 1 and 1 with input 0. So 1 and 0 is 0 and 0 X is 0, so we have 0, 0. So again AT from 1, 1 will remain at 1, 1. Then again we take state 1, 1 with input 1. So again the value of B and X is 1 and X is 1. So again now both toggle inputs are activated. So this state change from 1, 1 to 0, 0. So now we have the states at 0, 0 to 0, 0 with input 0, 0, 0 to 1, 0, 1, then 0, 1 to 0, 1, 0, 1 to 1, 0, 1, 0 to 1, 0, 1, 0 to 1, 1, 1, 1 to 1, 1, and 1, 1 to 1, 0, 0. And this is the final output, which is the product of A and B. So you can see the AND value of 0, 0 is 0, 0, 1 is 0, 0, 1 is 0, 1, 0 is 0, 1, 0 is 0, 1, 1 is 1, 1, 1 is 1, and 0, 0 is 0. So now this information we will depict on state diagram. So this is the state diagram. If we see the first row, the state is from 0, 0 to 0, 0. So this is self loop with input 0 and output is 0. So how we have predicted? So we have 4 states 0, 0, 0, 1, 1, 1, 1, 0. So first row depicts this transition 0, 0 to 0, 0 with 0 slash 0. So the numerator is input and the denominator is output. So with input 0, the state transits from 0, 0 to 0, 0 with output 0. Now if we see second row, we have 0, 0 change of state from 0, 0 to 0, 1 with input 0, input 1 and output is 0. So you see from 0, 0 to, we have 0, 0 to 0, 1. So 0, 0 to 0, 1 with input 1 and output is 0. So this is next transition. If we see third row, so it depicts the transition from 0, this self transition 0, 1 to 0, 1 with input 0. So 0, 1 to 0, 1 with input 0 and output 0. Then if we see fourth row, the 0, 1 to 1, 0 with input 1. So 0, 1 to 1, 0 with input 1 and output 0. So we have this transition. If we see next row, the 1, 0 to 1, 0, that is called self transition with input 0 and output 0. So we have this transition 1, 0 to 1, 0 with input 0 and output 0. Then we see next row 1, 0 to 1, 1 with input 0 and output again input 1 and output 1. So we have 1, 0 to, this is 1, 0 to 1, 1. 1, 0 to 1, 1 with input 1. So we have 1, 0 to 1, 1 with input 1, output 0. Then we have 1, 1 to 1, 1. 1, 1 to 1, 1 is input 0 and output 1. So we have 1, 1 to 1, 1 with input 0 and output 1. And last we have 1, 1 to 0, 0 with input 1. So we have 1, 1 to 0, 0 with input 1. And like this, we have generated a state diagram. So this is how we analyze. So you can see we have two processes. We can summarize it. The two processes are we generate a state table and we generate a state diagram. Thank you.